Alright, hey everyone, Lazy Ben. There I am. Hey everyone, Lazy Ben. It's Thursday. Gonna finish off this first pass of the world map stuff today. As ever, I've got my coffee. Let's put some music on. Some lovely stream friendly, royalty free, lo-fi. Where was I? YouTube music. Okay. Alright. So let's recap. Yesterday, what did we do? We spent 3 hours debugging a light problem. Well, it wasn't really a bug. It was I couldn't remember how it worked. But we fixed that. And then we spent the afternoon putting in this little, what will be the world map for fast travel. So today I think I just want to work a little bit more on this map. So the game's going to be broken. There's going to be multiple rooms. And the rooms are going to be linked together. They're going to be linked together geographically. So the question is, like, how do we want this world map to even look? If they're linked together geographically, we could have squares which represent the room, and then doorways which represent to the next room. So we'll have to come up with some kind of very clever, logical way. Well, we could either come up with some very clever way to code that automatically. So it automatically happens when I create the rooms in the editor. Or we can just draw them and have them just as assets imported in. Games do it both ways. Because this area is not very large, there's a third way where we could have it room by room. So you click the room you want to go, so it'd be like crew quarters. You click on it, and then it loads up crew quarters. And all the locations in the crew quarters that are relevant to the world map. Problem with that is there's only gonna be, so this is for fast travel, so it only really needs to highlight the actual fast travel stations, and there's only going to be one in each room. Oh, maybe there might be like more than one in each room. I don't really know actually. Don't really know how I want this to go. What I think I might do to get this going, something a little bit easier, is just implement zoom, so I can zoom it by scrolling the mouse wheel in and out. So we could do something like when you zoom out, it goes to a different view, which is just the rooms, and then you can zoom back into the room and it will show the location. Maybe it'll show the actual location you can click on. Yeah, we'll start with zoom. We'll start with something a little bit more straightforward. So that is in game menus. The fast travel menu. Draw world map canvas. So zoom, we want the zoom to happen if the camera input is hot. So if the camera input is hot, then we want to get the wheel delta equals canvas get input window. Or do we have anything to do with the mouse wheel in here? No. So get input window, get mouse wheel, and then we need to zoom it based on what that is. So we need like a zoom delta. So we'll just say auto zoom delta. We'll say just say 1. I'll say wheel delta. Whoops. Divided by, say, I don't know, 8 for now. Now there's two ways we could do zoom. We could set a target and zoom to it, or we could just, the simplest way would be to just set the zoom directly. So we'll set the zoom directly first, and then we'll set the target one, and we'll see which one feels better. So this is world map camera zoom plus equals wheel delta, and then we want to clamp the world map camera zoom to a minimum and maximum value. I don't know what we want. 0.1 2. We'll say 0.1 to 2 for now, and we'll see how that looks. It's gonna have to be something that feels natural, I think, to mess about with those figures. Okay. Alright, so I'm automatically zoomed out hugely. So what is that then? It automatically zoomed out to 0.1. So what is the camera zoom initial value? 1. Have I got this the right way around? No. Oops. Let's try that again. That's quite, 0.1 is quite a far zoom. Probably don't even need it to be that small. That zoomed out even. Alright, so that delta is obviously way too big. Let's just see what it is. I thought it was -1 and 1. It's obviously not. So 0 is -1. Okay, so what's going on there then? So we're setting it to be minus an eighth. So we're minusing an eighth off there. So we're going to say if wheel delta is break. Oops. Yeah, let's just get rid of that. So we'll break there. -1. Camera zoom is 1. Oh, yeah. Because we want it to be zoom delta. Silly me. Alright, let's try that then. There we go. So it zooms around the center. So it always zooms around the center of the screen, which is what we want, rather than coordinate 0. That's a very, very far zoom. I think 2 is right. I think possibly maybe that is as far out as you want to zoom. So what value is that? 375. So we'll set this to 0.4. And maybe this should be an animated zoom to make it feel... We'll try it with an animated zoom to make it feel a bit nicer. See how it just, that's like immediately in. You could actually like zoom it in over time. So that's far out as you can zoom. That's as far in as you can zoom. Now, we probably want this as well. We want this to stay the same size. On screen. So how do we do that? Where are we drawing this circle? Circle. So let's just draw this. Let's draw it. Draw a circle. We want canvas world to pixels. Location position. And then we'll set it to be 16 pixels. So that's, we're going to draw it in screen space instead. And that should keep that circle the same size. As we zoom. There we go. Probably needs to be, and the input box needs changing. Needs to be smaller than that. Let's try 8. All right, good. The input box is there, look. And I'm going to zoom right out. So the input box that we detect in when the mouse is over it also needs it needs to just be a normal input box. And so we need to do pworld is that pscreen even, and that needs to be pscreen inflate by 8, and then it's pscreen. All right, see if that works. Hang on. No, that's inflate by 4. No, they're both the radius of 8. So, yeah, this is pscreen. This is location bounds. But width. This is location bounds. Center. Another 2. All right. So that's exactly pixel perfect. Well, yeah, it doesn't matter how far we zoom in. Zoom out, it's all the same. Cool. Okay, so let's put in an animated zoom. So between 0.4 and 2. So this is just a tween. Zoom tween. Okay. All the constructors, start and target. So 1 to 1. And then we'll just tick it. Zoom tween dot tick dt ease function ease function cubic in out, I think. Easing out cubic. And then we're basically always going to set it. So we'll probably do it here. This will lag behind 1 frame. We'll see how that feels. Zoom tween, then we set it. So when we set it, we're just going to say the zoom equals zoom tween value. And then we just do zoom tween dot set zoom tween dot value plus zoom delta actually clamped. See how that looks. Ooh, looks rough. So it works if I'm not. Oh yeah, so we need to say if wheel delta. It worked if I was not hot on the world map there. So if there is a change, we'll set it. Otherwise, we don't want to keep saying it all the time. Obviously, it needs to be faster, but you can see it's animating. Feels a bit rough though. It works for 1. Feels when I do that, it feels like it's too fast. I think that'll be fixed if we make this a lot faster. So let's just say we'll do it 10 times as fast. But let's set it the target rather than the value. Let's move the target. See how that looks. So it chases the target rather than just tries to reset. Yeah, let's try that. So it doesn't. It takes a while. I think the ease is kind of wrong. Feels like it's happening too long after I've done the mouse wheel. So if we take that out, it just does a linear like tween. Don't know what's better, really. Maybe it needs to be faster than that, even. But it is zooming over time. That feels quite a lot better. So the question is as well, do we need a third button, which is like, or a third option kind of thing, which is locate it on the map? Yeah. So if we click that, we could have like locate on map. Or we can click that and then it just locates it on the map, and then we can click that. Clicking 2 buttons to fast travel though, or more than like clicking, that's already 2 buttons. That would mean you'd have to go locate on map, click it, click locate on map, then click that, then click that. So that's like 4 button presses to fast travel, which is too many. But you might just want to locate it on the map. So we could break this up into sections. Transport to room 1, and we could have transport to fast travel, and then we could have another button which is locate on map. Yeah, we'll do that. We'll try that out. So that means that this, for each location, we're gonna have a separator, which is lock s.kind. And that goes in there. And then this is just travel. And then we're going to have another one, else if canvas.draw button locate on map. See how that looks. Remember, it just has to be functional. We're not really concerned about how it looks, to be honest, because we're going to do a proper UI pass. Fast travel, locate on map. We're going to do a proper UI. Yeah. Proper UI pass where we'll change how everything looks. We'll keep the functionality the same. Change how everything looks. So set the initial state to true, which means it'll be open. And then the locate on map just needs to set a target. Here it is. So we've got transporter room 2, fast travel, locate on map. So I might just put in another transporter room, a fake one. Yeah, transporter room 3. So if that's just the way it is, actually, we can automatically do this. Do we want to create one for the unknown kind? Probably not. So we'll start that at 1. And then in the world map controller, we'll say we'll create one for transporter room 3. And we'll say that is 5 minus 5. Let me just do that. Yeah. So we've got 3 fast travel locations now. I just wanted to see what it looks like to have 2 on the map. Okay, so it doesn't have a name, and the buttons are wrong. The buttons need unique IDs. So why doesn't it have the name? That is strange. Transporter room 2. Transporter room 3. That means it probably needs to get rebuilt, which is unfortunate, because it hasn't actually. Try and just rebuild this one file again. Let's see if it's definitely adding them all in. is 1. Transport room 1. Transport room 2. Oh, missed it. Transport room 3. That is confusing. Transport room 2. Transport room 3. Basically, this is failing. This is a library that I use. Alright, I think we need to recompile, unfortunately. It's a shame, it's going to take a while to do that. Okay. Oops. Yeah, we can get on with this. So for locating on the map, that means we need to just go to it. We need the map to go to it. So I might actually tween this as well. Do we have a tween for a Vec2? We do. Cool. So tween tween Vec2. Position tween. Oh, I might just make this optional. So we only want this to be alive when that button is. I'm gonna press that button. Close all. Close Windows is not working. There we go. Let's go back to where we were. Okay, so we have this tween now. So we need here as well to the position tween, right? So position, if position tween dot tick et, and then we'll go. So does this tick return if it's at the target? Tween. Where is the tweens defined? Maths, maybe. No. In ease for some reason. So tick returns the value. Okay. So I think we can say if position tween t equals 1, so that means the tween is over. Position tween dot reset. Else, we'll tick it, and then we'll just say world map camera position equals position tween value. Okay. Right, now we've rebuilt, let's just check we can get the names of that fast travel station. There it is. Shame at the recompile. Like sometimes the compiler doesn't, or the Visual Studio doesn't detect that as changes happened in some of the CPP files. Not sure why. Unless you rebuild all. Okay, so it's like all of these have the same ID, which is not what we want. Where is this? This is the locations canvas. So we need to do UI scope ID canvas, and then we'll say s.id. Now that should give everything else IDs, everything unique IDs, sorry. Based on the fast travel station ID. See if that fixes the problem. Okay. There we go. So we've got transporter room 1, transporter room 2, transporter room 3. So fast travel should just work. Like it'd be interesting to see what happens here because transporter room 3 has not been defined. It just doesn't work. So if we fast travel transporter room 2, it should still work. Yeah. Awesome. So now we want locate on map, which means we just want it to tween up to the middle, like it's the screen, like that, and do some kind of effect. So if we press locate on map, we need to do position tween. Oh, just ban this bot. I kind of get a bot at the same time every day. Banned him. We banned him, but it didn't disappear the message. At least on my end. I don't think you can see it on your end. Okay, that's fine. Refresh the chat. Good. So position tween dot set position tween equals tween vec2. Well, if there's a position tween, we'll do position tween set we need the position of it on the world map. So we need to get the actual location. Get world map controller. Get location. So we need to get the location based on the ID. So it's optref world map location. Get location. So we'll just do locations.find ID. So get the location of s.id. If location, so if you have one, if the position screen, we just set it to location position. Else, if there isn't a position tween, we need to position tween equals tween vec2 start and target. So the start is wherever we are, so that's world map camera dot position, and the target is location position. All right. So we can't find world map location based on ID. No. The bool operator equals uses for other ID. Turn ID to other ID. And we'll put that in the source file. Let's see then. I think what we also want to do is if the world map becomes focused, which we need to do position tween.reset. So if you click on, say it's traveling a long way, it might take like 1 or 2 seconds. If you click on the world map, it just stops it. Right. Transport room 3. Transport room 2. And it should probably select it. So then you can just say fast travel. Oh, that works anyway. Alright, cool. So we'll make this look a little bit nicer. How do we do that? Position tween, we'll tick that with in-out cubic. And we'll probably tick it a bit faster. Let's say like 5. And then we should probably like radiate out something, like a little, we'll just do a little, we'll radiate a circle out. Yeah. So we'll just say all we really need how does onTick even work? onTick game UI canvas. Was it on in frame? How does this work? After, before frame tick, here it is. Let's just see where I've used this. So as a ticker, and we just call ticker.end when we want to stop. Okay. So we just want the position. So auto center equals position tween dot target. We'll just pass that in. So what we want to do here is we want a radius, and we'll just pass that in. And we'll make it mutable so we can change what this radius value is. So we'll do radius plus equals dt. If radius equals 1, like is greater than or equal to 1, ticker.end. We'll call this radius, we'll call this scale. It's going to take 1 second, so this ticker is going to happen for 1 second. Else, get game canvas, get game state. No, it's not the game canvas actually. We need to pass in this canvas. Canvas dot draw circle outline. The position. So this is actually canvas dot pixel world to pixels. We'll do it in screen space. So it's center, and then we're going to do scale times 16. Say 16. We'll float color. And then we'll just draw it right at the front for now. We'll just see what that looks like. So that's just going to like radiate out a circle. See how that looks. Didn't see it. Maybe actually needs to be 16 plus that. Well, what is the radius of these little green dots? I think the radius is 8. Well, that'll go 16 to 32. Oh, actually, we cannot do that. We cannot do that. Alright, that means we have to do it on the game canvas. This makes it a little bit more complicated. Or we do it right here in place. Yeah, I think what we're going to do, we're going to do it right here in place to keep it straightforward. So we do want we'll say we'll have another tween, and we'll call this the located tween, and then we're just going to say that this is optional. Like that. And then what we're going to do is we're going to so we need to store more than that though. Oops. We need to store the center value as well. Yeah. Where was I? So we're just going to go vec2 located center. So we're going to say located center is that, and then we're going to say located tween equals tween f and we'll say 8 to 16 like that. And then we're going to say if located tween and say if located tween t is 1, located tween dot reset, else located tween tick dt, and then we'll draw it here. So we'll just say canvas, draw circle, outline. The center is the located center. The radius is the located tween value. Set count 16, float color, do that. Int max. Let's try that. Value is not a function. So I'll just tween from 8 to 16 for 1 second. Should be quite slow, but at least it'll be working. There it is. Maybe on tween we could have a scale. Scale is just T, isn't it? So we could say we could fade it out. So we could say say alpha equals how do we want to do this? I think what we'll do is we'll say T equals 2 times located between T minus 1. So that gets it between minus and 1. So float A equals 1 minus T times T. So that will quadratically do this. And we could set that to be the alpha. So it'll fade in and out. And let's see what happens. That's quite nice. Let's see what this looks like if we put something really far away. So in the world map controller, let's put something at like, I don't know, 500. The fast travel, so transporter room 3 is 500. I mean, it doesn't look great. So maybe we need to scale it by distance, really. Because it's taking the same time no matter what. Oh yeah, that also. That screen space effect. Needs to change if we move the map. The way we would do that is rather than have the located center, we would have U64 located ID. We would set the located ID equals so we won't set it there. We'd set the located ID here. S.ID. And then when we draw it, the located center will be calculated every frame. So if equals get world map controller, get location, located ID, and then auto located center equals canvas dot world pixels location position. And then that should keep the so if we move the mouse while that yellow circle is coming out, it should keep the circle over the top of the green dot. Yeah, there we go. So maybe we want it to take a little bit longer to move there if it's far away. That means that this needs to kind of change. It needs to range. It needs to go down a bit. If we're far away. So if we change this to like 1, what does this look like? So that's what I would kind of expect, that kind of speed. If it was that far away. So let's put a 4th location in. For transporter room 4, and we'll put that like like 10 minus 5, or like, yeah, 10 minus 5 is fine. And in the fast travel controller, we don't need to make that anymore because we're making them all automatically now. Hopefully this doesn't require another complete rebuild. Let's see. So we need to alter this between 5 and 1, depending on how the distance that it's got to travel. So if we're at transporter room 2, right, and we want to go to transporter room 4, it's there. Transporter room 3, which is all the way down there. Maybe that's alright, I mean... That means it always takes 1 second. But we want it to take... This is 1/5 of a second. So the further, we need to go, so like, from basically, we need to scale between like 20 and 200 units. That's got a weird flickery thing as well. That's not quite working. I don't know what that's all about. So that's 1/5 of a second. Maybe we just say 1/2 a second for everything. Or we like alter this value depending on the distance away. I think we'll just leave it at that. Nothing's going to be 500 units away. Okay, so we also want a center on player button. The player just going to be 000 maybe. Right, I'm just running out of coffee, so I'm going to take 2 minutes to make a new one. I'll be back. All right. I think we'll just leave it at that for now. I mean, it ain't that bad. That's tolerable kind of time to wait, locate. Right, so we need to like make this geographically make sense, because I'm just randomly placing these on this map at the moment. Need to work out how that even how that is even gonna work. Because there's no kind of concept of this room is obviously to the left of this room. There's no kind of concept of that in the engine. I need to kind of work out how we would do that. You know, every room has origin about this 0, in world space, like every room. So I can't say that this room is to the right of this room. So it could auth this rather than try and automatically make it. I feel like we only need a couple of pieces of information to automatically make this though. And we don't have to draw it. That means every time we make a new room we would have to like author the world map for that room and tell it where it was connected. Alright, let's get rid of... let's put transporter room 3 and 4 in a different place. Well, transporter room 3. We'll make that 5 minus 10. Timber! How's it going? Are you saying make a kind of matrix for the map and the map locations? Yeah, I mean, I'm trying to work out how I would tell the game or the world map, like, so this map, this room is obviously to the left of this room, logically. But it's not geometrically. Like every room is origined about 0, 0. So I can't say where's the origin of this room. Is it to the left of the origin of the next room? What I do have, the information I do have is this warp trigger is to the left of this room and it connects to this room. So we can infer that this room is to the left. So I'm thinking something like that. Basically. I'm just thinking it through. So So I'm not particularly bothered about making the rooms kind of look similar in the map. I just kind of, this world map's like the first pass. So it'd be nice to be able to be like, automatically place these transporter rooms geometrically just about where they would be in the actual game world. Currently, we're in transporter room 1, which is like over here somewhere, and then transporter room 2 is like over here somewhere, and there are several rooms in the way. Now either I could just draw that, I could like make some kind of asset. I mean, it wouldn't be drawing, I'd probably write, you could write it. Probably, you could write it in code, where you manually lay out all the rooms. Or I could have the kind of, when you compile the game up, when you compile the game ready to run, I could put all, calculate all this information and put it in. Which is more difficult to set up, but then it means that when I add more rooms, they'll automatically just get added into the world map. So I don't know what's the best approach, really. Yeah, kind of. Exactly, yeah, that's right. And also, what would be more interesting to make? It would probably be more interesting to make something that automatically built the world map. The world's not going to be that big, so it wouldn't be much effort to just manually create the world map. But it wouldn't be as interesting, I don't think, from a coding point of view. Right now I'm just placing these, hard coding this coordinate. I'm just saying this is at point -5, or whatever it is, 0, or -5, -5, or whatever I said. They need to be set by the result of what this system, and then the player location can be somewhere. So I imagine it's kind of like we'll be drawing a rectangle. So transporter room 2 would be like a rectangle like that, and then it would have transporter room 2 there, and then it would be more rectangles, and then a rectangle, and then transporter room 1. That would be the kind of thing it would end up with. And then I could make the rectangles the same size as the size of the rooms as well, so you'd get the actual scale right. And even if a room is not rectangular shaped, I could work on that later when I actually start thinking about how the world map is actually gonna look. Because this is just like an alpha mask, which I can use to generate the actual shape of the room on the world map. So I think that'll be quite straightforward, because I'll just use the alpha mask to get the shape. Just do some kind of like, flood fill or something. We'll see. But that's going to be much later on when I start looking at the visual, like how the game's going to actually look. So what I think we'll do is we'll draw a little world map up in the corner. We'll draw a room, a rectangle, and we'll just start placing stuff in it. And then the second part of the problem is locating them in here. Maybe. don't know. Alright, the simplest thing to do is just do the rooms themselves have a bounds. I mean, we're definitely going to need that. So, when we compile a level, so let's have a look at game level. Room, level room. They don't have a bounds. Alright, so we need to make that. And the bounds can probably just be calculated based on the floor. So in the level compiler, level generator, append composite image groups. Is this what it is? They do append content to level. So we could go through all of the sprites in the room and use that to calculate the bounds. Pen sprites. Here's the thing, I think composite image group is the flaw. Let's just rebuild the levels. And we'll see what composite image groups is. Oh, nice one, Timber. Yeah, I think it's a great idea to get the, the basic data structures down. Often people don't concentrate on that stuff. But I would learn all of the basic data structures. But yeah, happy studying. So there's 11 composite image groups here. So this, I'm pretty sure this is the flaw. It's just added into the sprites as well. Alright, so I think all I'm going to do is when we draw the room, tick room. A room has in it sprites with a sprite has a room ID. So I think all I'm going to do here, we could base it off the floors. That might be a good idea. So let's just do with my bounding recs, right? And then we'll just say auto index is that, and then we'll just go bb.add level sprites index local bounds translate okay, we're going to cache this out. Oops. So sprite dot local bounds dot translate sprite dot position. So we'll build up this bounding box. And this is for a room. So we'll get this to return the bounds. Right? So we'll just say return the bounds. So this would be the bounds of all of the floors. Append to room ID. And does this happen for every room? Yes. So this would be auto bounds equals that. And then we'll get this to return bounds. And so this is auto room bounds. Just that. And then level rooms, room index. Then we need to set the bounds. Okay. We have room size, look. Ready. Oh, we already have it. Okay, no, that's great. That's great. Let's just chunk all that then. Oh, that's mint. Right. So that means that in the game level we can just draw it. So game level. I mean, maybe we have it. That's the problem. Hang on. Because that might be that actually set in the editor. Size might be a different thing. Yeah, I think that's correct actually. That's not the right size. Let's go back. Let's put all that back in. Morning. Is this my full-time job? It's what I spend most of my days doing. I also occasionally, so me and my wife have a business that we run together. So I also occasionally help with that. But that's not really full-time. That's every, like I'm helping tomorrow, and then last time I helped with it was about 2 or 3 weeks ago. I used to work in that business a lot until about 3 or 4 months ago. And then I went to do this. This is like, this is what I want to do. Just want to sit on my own in a room and make a game. I can do it 4 days a week, and then I usually spend Fridays making a YouTube video or editing a YouTube video. Okay. We've got a problem. This. What's the problem? Yeah. It's kind of tough out there, isn't it? Prosto Cottiolo. How's it going? Prosto Cottiolo. Yeah, it's kind of tough out there. Mortgages have become very expensive. If you've got any questions, then feel free to ask. Alright, whatever. We'll just... Well, let me do that. Oh yeah, because it's a pending child stuff in as well. So that means this needs to be a bounding rect, which we pass in by reference, and then we'll do auto rect equals that, and then we'll just do bb.add rect, and then we we'll just have it here now. So check that builds. So now we can set the room, so the level room will have a rect in it. So after camera, saved camera is not part of it, so we'll do it after weather. Rect bounds. Now we'll do it after size. Size is set by the editor, and that could be different to the bounds. So you might want the actual size of the room the camera uses it. So that's after size. We go room.bounds. Okay. So let's have a quick so this happens for every room. So I think we need to do BB reset. So we could just pass it in here actually. It doesn't really matter. All right then. See what happens. Sunburns, is that how you say your name? SMBNS, Sunburns. Are you a coder? Is your job a coder? Do you do something else? I tried to be a coder, but I didn't really like the corporate coding world. I'd definitely be a coder on a team of, 3 or 4 people, but nothing bigger. I might pass this in because that's a bit confusing why I would have to do that. And I'll forget. Let's just see if this works first. Alright, so does this give me the bounds of the room? We reset it, so it's invalid. When we do that, it's valid. Minus 16 plus 16. Minus 16 to plus 8. Well, that looks kind of alright. So we just need to do level room index dot bounds equals BB. And then I think I will, rather than pass this in here, I'll pass this as a parameter. Bounding rect. BB out. BB out. And then this is BB out to add rect. BB out. And then this is just bounding box BB. BB. Alright. Okay. Right. So let's just compile all this. Compile this data up. The asset compiler. Okay. And then what I want to do is draw this bounding box. So in game level, tick room, I'll just do canvas, draw, it's in world space, so draw quad outline in world, it's here, oops, we need the room. Room bounds pixels to world, just draw it white. Looks too big to me. That looks kind of right though. No, it's not too big, it's right, because the bounds are multiples of 256 pixels. Ooh, there's nothing in there because there's no flaw. There's always going to be a flaw, I would suggest. Okay. So we do need the concept now then of what room is next to what room. Which means we got to go, basically, when we're generating the world, that can be stored in the world. So in the world generator, we have these fast travel regions. So let's just build up, build the world again. So it needs to be probably all the warps. Will give us the information we need. As long as they warp to the next room though. So the warps do warp to the next room along. So if you look at the warps, there's 18 warps. And room to room is what we want. And we can see that that warp is to the left of the origin, and the destination is to the right of the origin. So we know we can work out what room is to the left, what room is to the right. So if we did the one that went down, I feel this is possible. Okay, I think I know what I'm going to do, right? I'm going to draw make a test case. So we're going to say tick world map test. Oops. I'm just going to say auto canvas equals get game state. Oh, it's just BM. Let's just get game canvas. So we're just going to draw. We're not going to draw the room. So we're just going to go what we're going to do, we're just going to draw something. So we're just going to say, we'll say canvas built right, yeah. We'll go vec2 to right, yeah. Static t to room space. And then that's just returns t divided by 4, right? So we'll just scale everything down by 4. So we're going to go auto state equals get game state, and then we're going to go get current. Well, how do we do this? Tick roaming, level tick room, location being the current location. So get current level, auto location equals state dot get current location or get location. I'm going to go level tick room canvas. No, not tick room. Level get room. Do we have a get room? What we're going to do is we're going to say we've got get room size. We're going to do get room bounds. We're going to go auto bounds equals get room bounds, lock room. That's optional as well. Canvas, draw quad outline. So let's just do times 32 divided by 4. So we'll do draw quad outline for room space bounds 1 float color 1 int max. Okay. No, T. Okay, so that's okay. Auto scale with 32 divided by 4. And then we're just going to return. So we'll explicitly say this is for rectangles. That's fine. We'll return rect t dot center inflate by t dot width over 2 scale times that scale times t dot height over 2. Okay, let's see what this looks like. So this should just draw like a rectangle that's a bit smaller than the current room. Once it's compiled, there it is. So we also want to push it to the center of the screen. So this is canvas.get client bounds center at. What's the problem? Okay, so this is auto offset. It's that. I should translate it by the offset. Oh, come on. This hot loading, Visual Studio hot loading is not that great. Okay. So that's this room that we're in. And then we want to draw the next room. It needs to be like kind of like this. Okay. So let's auto warp in get world, get warps. If warp source warp source dot room equals the current location dot room, then we need to get the dest, and so we know that we're connected to this room. So auto p0 is warp source dot position. Auto p1 equals warp dest dot position. I'll just say so let's just do this, but for a vector. Well, we'll keep it as a well. We'll say vec2 t, and this is just t. Not 0.5, not 0.5. So let's do canvas draw quad to room space E0. Draw them red. P0 being the warp connector in this room. So it's there and there. not right, is it? I think that's the times scale. There. There. Alright, that looks almost right. Apart from the Y is upside down. And fix. Oh, actually, maybe it's... Try this for a second. Canvas.world to pixels. T. And then... Well, let's just try that. We want to times it by scale. Let's just stick with this. All right. Is it? What is it? Oops. Let's work this out. So I think we just do t dot y times equals 1. Let's try that. Okay, we'll do it a bit different then. We'll keep the scale that, and we'll just return we'll do auto result equals t times scale, and we'll go return game canvas world to pixels result. Actually, and I think it's just times game canvas world to pixels scale. Let's try that there as well. Okay, we'll do this. T dot center inflate by T dot width over 2 times scale, T dot height over 2 times scale. Translate. Put this back. All right. Auto canvas is that. Leave the scale as that for now. World to pixel scale. Maybe that gives it. Alright, I don't think we even need to do this. Let's just leave it. And then let's just do it in a full bounds. D-Train, thanks for the follow. If you've got any questions, then just ask, no problem. Draw quad, rect. This is draw quad, outline in world. Alright, so we'll just draw it like that. I'll say 1. What's the current coding situation? I'm just kind of like messing about, trying to figure out how I might automatically generate a world map based on all of the level data that I've got. There's 2 approaches. I could just draw it, or I could just try and generate it. So I am trying the generation method first. It's for fast travel at the moment, but we could, use all this code when we actually do the world map. So I've got this is the fast travel UI, and I've got these places that you can fast travel to, but they're just hard coded on this map. So I want to be able to draw the rooms, and then the rooms that connect to the rooms, and then actually draw the transporter rooms in the correct location geographically, if you know what I mean. And obviously I could just hard code that, but I'm seeing if I can just try and generate all the information based on the level data that I've got already. And then you can he fast travels to it. So what I'm going to do here is I've drawn this box, which is the room bounds, and then these red outlines are the actual, they're the triggers that connect rooms to rooms. So that's a fast travel trigger, and then this is just a walk from room to room. And then I'm going to see if in a room I can draw the other rooms connected to it, you know what I mean? So I'll be able to this room's connected via fast travel to another room. I think I'm only going to concentrate on the room to room connectors. So this, what I'm trying to draw another room here, another outline box. But I just need to work out which room is to the left of this room. And it is this room. But I can't just say oh, is that room to the left, because every room is centered around the origin. Well, thanks very much, D-Train. No problem. Yeah, if you've got any questions, then just let me know and I'll try and answer them. Okay, so we only want to know, we want to care about if the warp kind, if it's not equal to E-warp kind, room to room. Let me continue. What language are you using? This is C++, and the rooms, I have my own editor here where I can basically paint stuff in. So I can paint more flooring. Like that. And then I make all these assets in Photoshop. And the engine imports Photoshop files, PSD files, everything. I'm not using Blender, no. Although Blender's awesome. I have used it before. Yeah, so this room's connected to this room. So I just want to draw like this rectangle here. So I just need to work out where to draw this. So like this box here and this box are like coplanar with the horizontal. Or, you know what I mean? They're connected on a horizontal line. So I can use some maths to calculate where the origin of this room is with respect to the space of this room. Just getting some kind of system in place, and then like I'll eventually start drawing it in this world map here. Oh yeah, and the NPCs can use the laser fast travel thing, which is cool. Okay, so if they share the same so we know we need to shift it by that distance. Okay. So we're going to say if P0.x is greater than 0 with to the left of the room, so we want to work out the other bounds. So test bounds equals level get room bounds warp dest room. So let's just draw this. We'll draw it a different color. Right. And then let's draw also the P1's connector in a different color. So what we need to know, we need to get the difference in Y So we need to get from there to there. So it's P0 minus P1. So so delta y is P0 minus P1 y, and that means that this has to get translated by delta y, and then this needs to get translated by delta y. Okay, so that puts them on the same y plane, and the x is x is more difficult. So let's just shift it from there to there, right? Which is in x as well. That puts them on top of each other. So the both warp connectors are on top of each other. Now the question is, do we shift it off the screen there, or do we shift it off the screen down there? I think we shift it, we have to measure the distance from there to there, and we take the smallest, and then that gets shifted that way. Okay, I'm nearly out of coffee, so I'm gonna take a 2-minute break. And then we should have this sorted. I think I know what I'm doing. So I'll see you in 2 minutes. All right. So they're on top of each other now. Let's get a banana. Get some energy. Oops. So we need to decide, we need to shift this one, in this case, over to here. Or, you know, if this exit point was down here, we'd want to shift it down here. Or if it was up here, we'd want to shift it up there. So the direction we definitely want to shift is from the center to there, right? So what I think we're going to do is we're going to go from the center to there is just P0. So we're going to go auto shift D equals vec2 I think so. P to X is greater than P dot Y. No, that's not it. Have a quick look at it again. So okay. If p dot x if the absolute value of p dot x is greater than the absolute value of p dot y, then then shift d to x equals the sine of p to x. Else shift d dot y equals the sine d dot y. Right? There's still a possibility that shift d could be 0 if x and y is 0, if p is 0, 0. So if you put the actual point right in the middle, we cannot really infer where it goes to. We'll have to deal with that later. Okay, so that gives you the direction that we want to shift. And then we need to shift it by that value there, which is the left of the room minus the right of that room. So we're going to go delta x plus equals this bounds x plus delta x minus So we're going to put source bounds. And that's not there. It's here. This can be source bounds. Minus source bounds dot right. No idea if that's right. It's P0. That's also P0. Oops. Actually, no, we don't need to do this. Let's say auto test is that. Let's not worry about that for a second. So the x just has to be equal to the left. So it's dest.x equals source bounds, the right, sorry. So we don't need shift D. No, that's if. So yeah. So this is if the sign is equal to 1, then we do that. Source bounds dot right, not an x, it's just is an x. There we go. So we've got that room drawn there. Now, we need to put this back in. So this can be desk room bounds, and this can be desk walk bounds. So the desk walk bounds also needs to be translated. What's the problem? There we go. So what happens on the other? So if the BM sign P0.x is -1, so the desk room bounds x equals the source room bounds dot x minus the desk room bounds width. Yeah. I think the delta is the same. So if we go into a room where we're traveling left, we can test that. Go to fast travel room 2. There we go. So we've got that room there now. So if we go to that room, we've got both of those rooms. Okay, so that works for rooms to the left and right. What about rooms from the top and the bottom? Yeah, so the way to test this is to just put this trigger up here somewhere. Which means it'll be in this case. Right. So we need to shift by so the Y is, so we'll test the sign. The Y of that room is the top of this room. Y. So old Y is the Y plus source bounds height. Let's see what that looks like. All right. That's it. And let's put this down here now to test that other case. I think it's going to be very similar to this one actually. Y, and that's going to be Y. Ooh, hang on. Source bounds dot Y minus dest room bounds dot height. Let's try that. Very good. Okay, so put that back there. We've got all 4 cases sorted now. Now, what we want to do is this has to happen for every room, starting from the current room. Because this only draws the room that's next to it. It doesn't draw the room that's next to this. Which is what we want to do. So we need to get... We know the new offset is the dest room bounds. Center. Right? So this is going to be like a recursive call, starting at the current room. I'm going through every single room recursively. Doesn't have to be recursive. Kind of makes more sense if it's recursive. So let's build it out recursively first. So static void draw world map room. And we'll just say const w string view room, and then we'll say vec2 const vec2 offset. We should probably do the level. What is the level? Optref game level. Well, we'll just say const. It can't be const. Game level. So let's just copy this into here. So we don't need the location, just need the room. And we're going to say, we'll get the source bounds. If not source bounds, return, I can't do it. And then we draw the source bounds, and I got else source bounds equals source bounds translate Visual Studio is getting confused here. Offset. So we translate it by the offset. Oh, it can't do it. It can't do it. So what we're going to do is going to say get room bounds dot value or the rect, the normal rect, the blank rect, and then we're going to, this is not going to be optional, so we're going to source bounds.area equals 0, return, and then we're going to do source bounds.translate to that, and then we're going to draw it to the new offset. And then we're going to get the warp, and if the room is the current room, then we call the get the des bounds, and we're going to go dot value or the rect, and then we're going to say if des bounds dot area equals 0, continue. And then else des bounds equals des bounds dot translate offset. Source bounds and des bounds are no longer optionals. Let's just see. Get this compiling first. Timber, just seen your message. Going alright, we've got the basics working now. I'm drawing the world map. Or I'm drawing the beginnings of the world map. I'm just now changing, I'm just now like implementing it further. So basically we've got rooms that can, get this compiling, I'll show you. Okay. So we're in this room and now we're drawing the adjacent rooms and we know where they are. We're working out where they are. And if you go to the adjacent room, we're drawing that didn't quite, that's not quite worked, that one. That one should be down here. Oh no, that's right, that's right. That is right. So you see how we're drawing the connecting rooms, and then we can scale all this down and put it on the world map. And these little rectangles are going to be where the fast travel locations could be. We're doing it for room locations at the moment, room to room warps at the moment, but we will swap it to do fast travel warps, so that these icons will be fast travel warps, and then when we put it in the fast travel world map, that's what we'll draw. Still kind of getting it in my head. But what's happening now is it's only drawing the rooms immediately next to it, and I'm making it now so it will draw all the rooms. in the whole world. And then we'll have the world map then. Or at least we'll have a way to get the world map. So we're making draw world map room, and this is going to be like a recursive. So we're going to start with the room we're in, draw the adjacent ones, and then we're going to go to each of those rooms recursively and draw their adjacent ones, and then go, you know, just spread out like that. Okay, so this is how we do that. And then we need to calculate the offset, which is here. And then that is plus the old offset. And then we're just going to go draw world map room for the destination. The warp dest.room level new offset. So to be drawing a few things, this might be we have to make sure that this doesn't blow the stack, because we can have circular dependencies between rooms. So what that means is we need an array of rooms that we've already checked. So let's make that a temporary array of U64 checked rooms. And then we're just going to go checked rooms dot add room dot ID. We'll just hash it room. Very Flundervar. Thank you. TAR 513. Thank you. So we need to check that. Yeah. So we'll add it. And then before we recurse, we just have to say if not checked rooms that contains warp hash 64 warp dest room, do it. All right. And we also have to pass in the checked rooms. Right then. So this is the first room here. So we're just going to go draw world map room, lock room, level. There's no offset to begin with. Then we need checked rooms. And then we're just going to delete this. All right. Let's see what happens. So we'll step through it first. That's good to catch any easily catchable mistakes. Right. So we're in the fast travel room. So we add fast travel room to the checked rooms. And then we're going to do it so I wonder, actually, we could check here. So we could just say, if checked rooms contains that, continue. We don't need to do it at all. We've already done it. Let's try again then. Let's find one. So this fast travel room, the destination room is the test room. So we just basically go through this rigmarole to place the room. The new offset is the center of the new destination room. So that's where we're starting from now. And the destination room is the test room. So that's immediately an error. Got the reference. So let's go back to where we were. Right. We have a new offset of 40 minus 7. Okay. So this does go back to the fast travel room. So this test room now is test 2. So this is the room to the immediate, like, above. And then the next room. Okay, so let's just see what happens. Didn't overflow the stack. So it looks like these little ones are wrong. And they aren't quite. They're overlapping a little bit. Alright. Probably just not adding the offset on to the... Ooh, here we go. These. Alright. Let's try that. Okay. So it looks like there's a little bit of a... So the white is where it's the current room. And the yellow is the offset room. So that one. Okay. So it's not quite working. So that looks right. So what's interesting is it's not drawing the warp. The warp to the other room. That looks right though, this looks right. It's not 100% though. Okay. So we do need to fix these should be the same, I believe. So when we go into the fast travel room, Okay. Let's debug this then. So we're in the fast travel room. And then we want to find the test room. Which is that. Offset 0 at the moment. And we draw it. And we're going to draw it red. We draw the point red. So the desk room bounds there is minus 16, minus 27. (16 minus 27, 48, 40. Make a note of that. And the new offset is that. And then, so now when we come to draw the source bounds is this, and then when we translate it, it's minus 23. So it's slightly off on the Y. Why is that the case? So let's make the offset not the center, just the XY location. Should be the center though. This might be entirely wrong now. Yeah. Okay, so the source, so the destination, the warp's destination is the test room, right? So it's minus 24, minus 16, 48, 40. So we've got the Dest room bounds center. Hey, all right. Yeah. I've got one, thank you. So it went from 16 to minus 24, which is 40. Then it went from minus 27 to minus 16. Okay. So I think if we just do Dest room bounds xy minus Dest bounds Dest room bounds xy minus Dest bounds xy. What's the problem? Dest room bounds Dest bounds. Okay, so that's optional. Okay, so yeah. So minus 27 plus 16 is 11. Okay. So I think this is dot xy minus Dest bounds xy. So 40 minus 11. We have to add the offset on, the old offset on as well. All right, let's see what happens there. There we go. That's it. So that's the whole world map drawn out. So there's the other problem of what happens if we have two that go to two locations to the left. These need to get spread out. Everything needs to get spread out so it doesn't intersect. But that is working. So at any room, we can draw the world map from that room, which is pretty cool. So what's interesting is this has it going up, whereas that has it going to the left. Definitely should be an up room. So let's debug that. So I think that is because you go alright in the optician?
Hmm?
Did you go alright in the optician?
Oh, I've got.
You said you've got like some kind of damaged retina.
It's what's his posh name for it? A vitreous detachment. Got an insect flying around my eye.
But then your brain will ignore it after a while.
It's there all the time.
Yeah.
Have you had something like this?
So I have an underdeveloped retina. I think it's a birth thing.
It was a what?
It's from birth, I think. Mine.
What's wrong with your retina?
Just underdeveloped.
Oh, is it all right?
Yeah, I can see fine.
Yeah.
My it's this eye.
Yeah.
So this eye just compensates a lot.
Oh, yeah.
Yeah. I can tell because when I look down at my nose, I only see one side of my nose. So I know that this eye's doing all the
So you
looking.
got a bit of tunnel vision in one eye. You don't have
I can't
bigger field of
notice.
vision as one eye as the other.
No, I don't know.
Well, I got off a plane in Leeds when I came back from Prague, and I got something in my eye.
Yeah.
And I got I thought, what is it? It's like a spider. I
Yeah.
think what it is forget the name of it, but there's the thing that your retina's attached to, or the thing that's attached to your retina. Every now and again, a bit breaks off.
Yeah.
It just floats around in your eye.
Weird.
And what happens is it casts a shadow on your retina. So it's like an eclipse in your eye.
Yeah,
What
yeah.
you're seeing is a shadow that's been cast by this blob of crap that's in your eye. It's really weird.
Oh, God, yeah.
And it can happen to anybody at any age.
Yeah. Oh, God. Yeah.
And then, as time goes on, your brain sort of learns to compensate for it, so it'll just get better.
Good.
Probably had it before, actually. Like, they called me in sort of really quick to have a look, because if it's your retina falling to bits, it's macro degeneration, which is when you just can start going blind.
Yeah. Oh, is it? Oh. All right. So this one, the room should be above. I'm pretty sure. We need to debug. So we need to go into the next room. And find everything in this room. So the source room is the test room. This destination room is the test 2 room. So this is the one that should be above, I think. Maybe not. It doesn't have. Oh, it's infinite room. Infinite. Okay, no. That is a problem with the world gen stuff. Default, where are we? The world generator. No, not the world generator, the level generator. Oops. I can get to it. We only want to do this if it's valid. Yeah, that's fine. Else we don't have one. We don't want infinite rectangles. And then we need to rebuild the world. Nuke Bird, hey, how's it going? Hope you're okay. Alright. So we get here, and then we go to here again. Didn't work. Didn't work. Still said it was infinity. Because we need to build the levels again. Silly me. Not the world. To rebuild the levels. Just working on a world map, Nuke Bird. The very beginning of it, anyway. Okay, so it's now this should be 0. Oh, it's still infinity. Because that is valid. That is a valid. Okay, we need to check this then. Oh yeah, we all feel like that from time to time. Yeah, they can get outrageously complicated to look at and to deal with. For sure. In the game code, I tend to keep it to a minimum if I can. There is some library stuff that I've made which is quite template heavy, unfortunately. And you know, like kind of what variadic, recursive template stuff. Like, look at all this stuff. Basically impossible to read, but it's very useful. So I've hidden it away, and I don't actually use it like this. Like, you do want to know if a type is in a tuple, but to actually work it out, you need this. And this uses this. Yeah, so it's mental. But I use it all the time, so I need it in. Um, so append composite image groups. So for some reason, we are getting a rectangle that's infinitely big. It's because it's got no floor. It's the room with no floor has infinite. It's saying a room with no floor has infinite size. So I think this room's got no floor, this test 2. Room bounds. So what is causing that? Yeah. Yeah, my main workhorse is dynamic array, that's it, really. I don't use hash tables very much, or linked lists or anything. They are there, but they're not very much. Yeah. Yeah, C's lovely. Except I wish it had a little bit more. You know, I tend to like keep all the template heavy stuff hidden away. So all that crazy stuff I was showing in here, you don't use it. You just say for each type, and it takes a tuple. This is just a cycle through types in a tuple. So you know, didn't float like that. And then do something with it. Do something with each type. So you don't have to actually mess with the template stuff, want to use it. So obviously like the implementation's a nightmare. But once you've got it implemented, it's quite simple to use. Yeah, that's the C problem, isn't it? Right there. You can compile in C++ and use a very small subset of C++, which a lot of people do, and I used to do for a long time, and then slowly this template stuff it's come into my day-to-day programming. Yeah. Yeah. Yeah, maybe. I've never tried to do lambdas in C, other than basic callbacks. I do quite like a lambda. I use lambdas quite a lot. I like the idea that you can separate the location of the code in the file from the time it's executed, because you can do stuff like, if press button after delay of 5 seconds or 4 seconds, do something, which I quite like. So you can see that the execution of the time the code gets executed is separated from its location in the file. So it's not just like straight down, And I quite like that about it. Yeah. Yeah. Sorting is good. And I like how you can, standard less and stuff, which is a lambda. But you could wrap it, lambda's just a structure or a class with, when you override this. So you could write a class and you could override this, and then pass the class around to be executed later. And if I use that quite a lot. So where is it? Where would it be? Game state events, right? I have these classes which are like event group classes, and they're just all these parentheses overridden. And then I just pass, so there's like loads of them. This is for all the events you want to handle. Load game, after load game, auto save, and then I just bundle all that up and send it to the listener. And the listener just can execute whatever it wants when the events happen. And I quite like that. So it's like a lambda with multiple executions dependent on the event. So if I wanted to just listen for another event, all I would have to do is just define another one of these. G event hello. And then it would just automatically start getting called. I don't have to go to the place where it should be called and then start calling it. I just write this and then it starts getting called. And I quite like that. That's quite nice. Can't really do that in C, I don't think. I mean, you might be able to. Might be some crazy way you could do it. Do you mean by FSM? Something model? Or finite state machine? Yeah. Yeah, it's a very useful design pattern, I think. The way I tend to work is I make systems that don't care about... So the game events in general... you just define it to make a game event. You just make a struct and you call it whatever you want, but I call it like G event hello. Put whatever into it, and then you add it into the events list, and that's all you've got to do. You don't have to worry about when to call it and stuff like that in the code. Like, the event system looks at that big events list and it goes and it knows where to send the event and stuff like that based on, whether you've implemented these methods or not. So you write systems that can handle kind of like, it doesn't matter about what data you send into it. Then it's really, really flexible because you can just expand them and expand them and expand them, and it's really easy. What do I think about coroutines? Yeah, it's hard for me to find a use case where you can't just do it normally. That's the problem I have with them. I think they're kind of a buzzword in programming at the moment. And I've never if I came across a use case, I would use them. Because I am bound to like what kind of standard. I could use whatever standard I want because it's only me programming. So I could go, right, we're going to start using C++ 26 or whatever. But I just, people say you use them as generators and stuff, but it's just as easy to write a generator the normal way. Yeah, I mean, if I started using them, maybe I would find them useful. It's just I'll tend to start using something if I think, oh, that'll be a cool place to have a coroutine. And the thing with C++ and stuff, that you have to kind of study how it actually works under the hood to make sure what you understand any implications, like what is happening to memory. When you use a coroutine, is everything dynamically allocated on some heap that you don't control? And if you start wanting to control the memory allocation, how do you even do that? If you want to control it yourself and not just have standard template library just call new all the time. So for instance, if you use standard function, as far as I'm aware, that could be huge amounts of memory allocation, which you care about if you're making a game. So if you want to use lambdas and you care about memory allocation, you kind of have to customize standard function somehow, or write your own standard function. So, in other languages, you don't care about that. In Python, you don't really care about what is happening to my memory. Yeah, so standard function will allocate. So you've got the function signature, and then you've got the capture list, right? Check that builds. Got the actual syntax for it, right? Oh, actually, I need to actually do it. Yeah, we've got to return the. So, if you were to put like int eyes 10,000 or whatever, and you were to do this, all of a sudden it's allocating loads and loads of memory because it has to copy this in. So you need to be aware of stuff like that. And then of course, if this is some kind of like crazy class with copy constructors, and then the copy constructors copy things that have copy constructors, all of a sudden there's a huge amount of work that needs to be done. Yeah, so you could pass by reference And that would work okay as long as this never went out of scope. So all of a sudden you have to think about, oh, what's happening to this? And you might have a few of these. So it's like when you consider, I think, you know, when you consider something like coroutines, you need to know all this stuff basically in order to use it effectively in a game where you care about how fast things are and how much memory is being allocated. You know, which you would obviously, if you wanted to use coroutines, you'd go and learn all that stuff. So what I did is I made my own thing called a hybrid. What is it? So I made something called a hybrid lambda, right? Which is standard function, except you can pass in as a template parameter a fixed buffer size that is stack allocated, which means that if you know how much you're going to pass in, so let's find a use case. So here, so this is like a lambda with the signature, right? But you're passing, oh, I want a 32 byte buffer in the lambda that's stack allocated, or automatic storage, you know. It's allocated there. So there's no dynamic memory allocation as long as you stay under 32 bytes. So if you know what you're going to pass in, and it's going to be just like 32 bytes of stuff, it just allocates it there on the stack. If you pass in something that's bigger, it'll then do its dynamic allocation. So it's like standard function but extended a little bit, just for performance. So when I like start using after move to target, somewhere, I'm passing in a position there which is just 8 bytes. So it's not gonna dynamically allocate 8 bytes, it's just going to put it directly in the lambda. Then you've got old template gobbledygook again. I have unit tests for, so here there's this libbm here is a general purpose library that's not really targeted at games, it's just general use. So this has got stuff like the hybrid lambda and dynamic array, and it's got a bunch of image processing things in there, which in another solution I have unit tests for if I ever want to test that stuff. But then the game doesn't have unit tests, no. What I'll end up doing is if something needs to be validated or tested often, I might write some custom thing for that. But stuff like, you know, I want to compress an image to some different image format. That stuff can be validated, so I have unit tests for that. But I haven't used them for a long time because I wrote libbm quite a long time ago. But that's all, you know, my version of STL, I suppose. Got a bunch of stuff in there. It's not STL. I haven't re-implemented STL, but it's my version of like my utilities library. Okay. So we were figuring out why this is returning infinity. Um, yeah, like when I get more and more into what the game is actually going to be, I might find some useful places for stuff like that. When I need to validate, you know, I can imagine I could validate that all the crafting recipes work if you have all of the items in the inventory that you need and stuff like that. I imagine you could do something like that. Yeah, very useful for maths libraries. Very useful for things like writing files, reading files. All right. So, and oh wait, append composite image groups. I believe if composite image groups has no size, that would be where the error happens. So we'll test that. Rebuild the levels. Yeah, and I like how Visual Studio has built-in unit testing framework where you can just start executing them all. So in the other solution for the BM, it's got one of those, and it just tells you how many passed and how many failed and stuff like that. Let's check I didn't actually leave that standard function code in. Game state events. No. So we need to get all the bugs out of this, and then we need to kind of formalize all this code in some way so that it can be used by the world map. We'll probably put it in the world map controller, and then you just give it a canvas and it draws the world map on the canvas. We need to get scaled down though. Alright, so let's see if we actually trigger a breakpoint here. I know at least I didn't. I know at least I know that test room 2. So let's just see which actual room that even is. Rooms test 2. So this is the one with no floor, but apparently does have composite image groups in it. Right, well, we'll just have to step through all this. Yes, I've got a bug now where if a room has no floor, it gives it infinite size. Append, where is it? Content to level. Room files. So we'll have to just go through one at a time. Right. Just gonna go get a quick cup of coffee. I'll be back in 2 minutes. Alright, I'm coffeeed up. Let's get back to work. Try and solve this problem before I have to go today. So it's test 2 we want. Crafting, data, downloader, fast travel, planting, shop, test 2. Right, this is the problem. This is where the problem is. Pen content to room. Append, so BB out is invalid. So it apparently got 11 composite image groups. Oh, I know why. Yeah, there's the composite image groups app per room for everything. So we're going to put a breakpoint there. Whoops. Didn't mean to do that. And a breakpoint there. So there aren't any. It's still invalid. So it's when you add an invalid rectangle to the bounding box, it somehow makes it valid. Right. Because it rightens it. All righten means is if it has a negative width and height, it flips the rectangle around to make sure it has a positive width and height. There's nothing much we can do about that. So what we have to do here is valid return bb.getRect, else just return the rect. I don't like the idea that you had an invalid rectangle, an invalid bounding box. Yeah, it's... The problem is that the bounding box can reduce down to a rectangle. So we could check here. Like, I don't want to assert that it's valid. I don't want to start crashing just because we don't have a valid bounding box. I think I'm going to say if not is valid, return auto result. Well, yeah, return but we're just going to put 0, 0 there. Because I mean, we won't actually write 0, 0 because this might not. And that will set the rectangle to be have no size, which I think, you know, is the safer option. Okay, so if we rebuild these levels again, oh, we're gonna have to rebuild a lot of stuff now. At least now we won't be getting infinite rectangles. got 1 hour. 1 hour left of the stream. Try and fix all this stuff. So we have a slight problem with this code. Nearly there now. Yeah, changing the bounding rectangle was a bad idea. Triggered a very big rebuild. Alright, okay. Okay. Go to this. So this now is test 2 and it has no area. Brilliant. Okay. So the problem that the bug that we have is that the second room here is to the right of this room that I'm in now. But if we go here to this second room, it's now above. And it should be above. So it's this first case that's wrong. So when we go into the test room, and then this is the destination, so this is the one that has no size. This one here, which is a planting room, it should be above, and it's putting it to the left. So it's 43 minus a half. Is that right? So the warp Ah, yeah. Yeah. Okay, so I believe that is fine. This is not fine. Okay, what I might do here is do auto p-test. That's relative to the room. That's not relative to the whole kind of map. Right then, so where is it? It's above now. Brilliant. So another thing about this is it could be quite expensive if there are a lot of rooms. Like, we only want to really draw. If we're assuming rooms are next to each other, like, we only really want to continue the path if we're on the screen. Yeah, the problem with that is that rooms might go off the screen and then they might be connected to rooms that come back onto the screen. Let's just time this. Got a timer there. And see. I mean, this probably is pretty quick, but if you imagine you had... Well, how many rooms are we really going to have? And the other thing we need to sort out is what happens if rooms do naturally overlap. In the physical world, rooms never overlap. So this would work if it was a real building. But I might accidentally draw a room too big. You know, if I drew like... If I drew, you know, a room that went off onto here and then it came across here like that, I need to like push them apart. Well, this is taking absolutely no time at all. It's taking 0.05 of a millisecond. So I think we'll just leave it for now. And if it becomes a performance problem, we will deal with that then. So let's set up the situation then where we do have rooms that overlap, which means let's go in, let's create a new room. just call this overlap dot room. Make a new layer, floor, and then let's paint down some floor. Okay, so what we want to do is we want copy this trigger ID, and then we want to go up here. I'm going to put another trigger light here saying that it goes to this overlap room, right? So we're going to warp to the overlap room when we enter this trigger. And then this one we're going to warp to back to the test room when we enter this trigger. Alright, so let's see if that works. So what we'll see now is we'll see hopefully two rooms overlapping because they're both above, and we need to shift them apart somehow. You see they're overlapping now. Which means that this one has to get like pushed that way. Which means we need to do some kind of like separating axis thing to push all the rooms apart. That is definitely not going to get that done in the next half an hour. I mean, we could try. So that means planting all the rooms. And then pushing them all apart from each other. Which means repeatedly iterating the rooms, finding collisions, resolving them until there's no collisions left. Now the great thing about this is, although that might be quite expensive, all this can be done offline before putting the game's data, all these world maps. So eventually this will, you know, the game will just have a list of all the room bounds. So it doesn't really matter that it takes a long time. Okay, so we'll do that. So I think to make things straightforward, we're just going to have a structure called world map room, and we're just going to have the name, make that a proper string, and then the bounds. And we also need the bounds of any warps. And we probably should actually also have what is connected to. So this could be like, you know, for this warp, these are the bounds. Okay. So we'll just say, we'll make it tier A as well. Of world map room. Output. Okay. So output is just in place. World map room. What's going on here? Okay, so we've got the name, the bounds, the warp bounds. Alright, so this isn't as straightforward as that. Bool operator. So we need to go auto index equals output dot index of the room, and say if index equals output dot get count. Now we can add it in. Index equals output dot in place world map room dot name room dot bounds, what bounds equals the source bounds, and then we need to add in warp bounds and the connectors for so this is the source warp bounds. So I could probably do this here. And this index is world map room index. So we need to add an array of those in. So TArray world map room rooms, and then this is rooms, and then this is rooms as well. Rooms on, oh, this is output, sorry. Yeah, so we know that there's no room. well, it'd be fine to just check it. We know that this has not been added in. And then for each warp now, we need to so output index dot warp bounds dot add test warp bounds output world room index dot connectors dot add whatever this is. It's just called warp. Okay. So let's see what we end up with. Nine rooms. The bounds are all 0. The warp bounds look right. Connectors look right. Oops. So why are the bounds 0? How did that even work? Oh, I just assigned it. So we're going to rename this room. Well, no, don't need to, because it's called a room. And that means we can take the drawing out of here now, which is nice as well. Draw in a separate step. All right, all the bounds. So we've got all the rooms. So this is the world map. So let's get rid of this drawing. There. Here. And then we're going to rename this calculate world map. Okay. Then we go for auto room in rooms canvas draw quad outline in world. Oops. Take that off. Room dot bounds. Pixels to world 1. Look color 1. Int max. And then for auto warp in room dot warp bounds. We'll draw all the warps red. Okay. So let's see. They should look the same if it works. Well, that's not right. I'm not drawing the warp connectors because this is warp. fix me hat. Okay, so it's only drawing one set of warp connectors. We're not adding in the source warps. So what we might do is this isn't 1-to-1 anymore. So it's 1-to-1 if we do something like this. Connector bounds. Source. Test. And then when we draw it, draw the sources and the dests. Different color. Now that they probably overlap. What is the problem? Why can't I do this? It's not warp connector. What do we call it? Connector bounds. All right. So the sources are red, the destinations are yellow. And it's from the point of view of the opening room. So these rooms now overlap. So now we need to spread them all out so none of them overlap. Right. How do we do that? So I think the connector sort these should be relative to these. which means we probably don't add the offset. That's all that probably means. Maybe. Which is nice because then that just goes back to being P0. And then for that to work, we need to do .translate room.bounds.xy. Oh, it's either .xy, I think it's .center. Figure it out. Alright, yeah, that's it. That's it. No, it's not. They're wrong. That should be over the top of there. Okay, so what? Translated by something. Okay, so I think if we keep the offset and then when we assign them in, so it.translate source bounds.xy, and we'll just minus it. We'll make it local to the room. And then this is just .xy. No. It's just source bounds.xy. Now that's also not right. It is the dest bounds. So let's just not draw that one. So it is the dest bounds. But we're going to be moving the destination around. So this, we need the destination index. Or the destination ID. So we need like W string dest room like that. And where did we put that? Sorry, right at the top. So put it at the bottom. And then we'll say dest room equals warp dest. We already have it. We already have it, don't we? Because we have the connector, which has the dest room in it. So yeah, I'm wondering if we should just put source room and dest room right here. And then not have this at all. Let's say warp.source.room. And there we go. We don't need to add the warp in. Okay. So we need to get the destination room. So auto dest room equals rooms dot find connector dot dest room. If we have it, then that is dest room dot bounds dot xy. And this is the source room. So it should just look the same, except we've made the connector bounds relative to the rooms, because we're going to move the rooms around. So if they're relative to the room, we don't have to worry about moving the actual connectors around. Okay, so the source didn't work. So the dest bounds We've lost our yellow ones. Okay, so Dest definitely doesn't look like a relative. No, I'm alright, thank you. These Dest room bounds. Source room bounds. Source bounds. So what's the difference between Dest bounds and Dest room bounds? That's the shifted one. That's the one that's come straight out. Yeah. Alright, let's try that. We're nearly in a position where we can spread the rooms. Oh, there we go. We're back now. Okay. So we should be able to shift any of these rooms around, and all of the warp connectors, these yellow and red rectangles, will stay in their room. Okay, so how do we do this? So Boole intersecting is true. While intersecting, we gotta go for each room. And we've got this thing called geometry axis. Compute minimum translation distance between two polygons. Now, let's have a look at the roaming code, because this does this. Is it there that it does it? It's get collision displacement, but that uses the collision geometry. Okay, so it's compute minimum translation distance. So that is the distance we have to move apart. That is the vector we need to move each room along by. So, but it's, unfortunately, it's in polygons. Okay, so vec2 poly A equals source room dot bounds dot top left, source room dot bounds dot top right, source room bounds dot bottom right, source room bounds dot bottom left. And then poly B is the destination room. we're going to say we're going to get the nut right. I'm going to get the test room. If not test room, so if there isn't a desk room, the break because it's broken. I have to say intersecting is false. Break. So it's poly A and poly B. I'm going to say if D dot D right, meaning that D's got a magnitude. So to think that intersecting is false. So if there's a magnitude, that means they are intersecting. So intersecting equals true. And this is like actually a do while intersecting, I think. We at least want it to happen once. And then we're just going to say reset it, intersecting is false again. Okay, so this will keep happening as long as this keeps getting set to true. So if it is intersecting, we need to do source room dot bounds dot translate dot bounds equals source room dot bounds dot translate by d over 2. And then the desk room by minus d over 2, and I'll push them apart. All right. Don't know about connector. What is connector? Okay. So I think what we're going to do is we're not going to find it. We're going to go for auto dest room in rooms. And then we're going to say if source room dot name equals dest room dot name, continue. We don't need to do that. We can just save their equal. Source room is the dest room. And then we continue. Else we do this check. All right, let's see what happens. Can't do that. World map room. Other room. If name is equal to other room dot name, then it's the same. Right, so let's see if this works. So it found intersecting rooms, which were the planting room and the overlap room, which is a good sign. And it wants to shift it 15 to the left, which is also a good sign. It's 15 to the right even. So that means it wants to shift the planting room 15 to the right. That's right on the screen, I think. So I think we want to shift it, do it that way around. 7.5 each. Now this will either not be able to break out of this loop, or it will. And it'll work. Oh, doesn't look like it's been able to break out of this loop. So the overlap room is with the planting room. So maybe we need to do it by DT. Shift them apart over time. Okay, so let's draw them as well. See what it actually looks like. We can't draw them because we can't get out. We're stuck in this loop. Okay, so we'll do it once. So we'll make this static and we'll just say if rooms dot get count is 0, do it. And then break, we'll just do this one frame at a time. Oh, okay. Oh, because it's a temporary array. We need to make that a proper array. Temporary array means it's going to eventually the memory is going to get reused by something else. Okay. So let's do that. So let's just move the desk room. Probably need we did move it out there. So let's try this. Oh, it's my alarm to end. Let's do that. Dist. And we also just probably want to translate it by this normalized as well. So just pushing. Okay, that's good. It's going in the wrong direction. So it shifted it out and then it got here and then it didn't go any further. Because this is pushing it that way, that's pushing it that way. Which probably means we need to do one at a time. So let's just do size T, current room 0, and then we need to go for auto room in rooms. So this is the desk room. So I'm going to go auto source room. Oh, the test room, or whatever, equals rooms current room. And that's static. And we'll go through, going to go for other rooms. We're going to go if test room equals desk room, continue. And then we're going to go source room, we'll call it source room. And then we're going to do this repeatedly on the source room. Source room index. And then we're going to do this. And we'll just push them both apart so they'll not intersect. Well, it could all, this is the problem, it could always end up being intersecting. This needs a bit more thought, I think. So let's just go back to where I had that case, because then we can resume that on Monday. So we may have to do something like where we average out the vectors. Can't average it out. So if the one vector's pushing that way, one vector's pushing that way, we actually need to push it that way. Let's just try this. Alright, I think I'm going to have to head off. Just pushing it out of the way. That might have worked actually. Let's go to game room. Oh, is it game level? Let me tick the room. Get rid of that. See, it's pushing this room out of the way, which is totally fine until it's not overlapping anymore. There we go. Anyway, we made good progress, so they're not overlapping. I don't know whether in all cases they'll be able to spread out like that. Anyway, I'm going to sign off. I'm back here on Monday, 9:30.